right, well, let's get started here. Yeah, let's get started. So this is our last day of class. You guys made it through. That's good. I'm going to go over the final voyage plan and other questions and things. And then we're going to do a little bit of electronic navigation, mainly GPS, and a little bit of that night navigation for you guys. So yeah, that's the plan for tonight. Did you guys get to mess around with the voyage plan at all? Okay. Let's get to it then. Any questions? Let's get to it. Okay. So I need a new chart, but so I did not do all the labeling on mine. Hopefully you guys labeled yours, but I did want to show you the. Oh, hold on. So do that. We had I hate all these things. Waypoint 1, which was the buoy. Let's see if that helps. There we go. Waypoint 1, which was the buoy, and then here was Long Point, Catalina. Waypoint 2. And so we connected them. I used a yardstick on this one because it was so long. There we go. We connected them. So that right there, that line just from point A to point B, or waypoint 1 to waypoint 2, that is our course made good, right? That's what we want to make good because that's the shortest distance. We want to make that good. So when we go to our voyage plan chart, it's not focused. Excuse me. Okay, so when we go to our voyage plan, and you can print out different voyage plans. I'm sure different websites have different styles and things. And if you guys like one, feel free to share it in the comments or something so the other classmates can use it too. So that was our course made good, but they gave us a set and drift, a current that we were going to be accounting for all of these legs. So when we let's do, if we go back to that vector triangle, right, we had yeah, course made good, speed made good, course, speed, and set drift. So our course made good, that was 255. So I know that that is going to be my course made good. True. Because that's what this angle is, or that's what this line is. Sorry, scoot over here. Then we have our next step is to plot our set and, or yeah, plot the set and drift, because that was given to us. 130 at 1.5. So we're going to draw, and remember these two start from one another. So we're going to draw our 130 and end it at 1.5. So this is going to be the set drift line. The last thing they told us was our speed. We were either going to make 5 knots or 12 knots, whichever one you wanted to do. So if you did, and that's going to be the other leg, right? These are all separate legs of our triangle. So if we do 5 knots, that one's an easy measurement to measure 5 knots wherever it hits. That is going to be our course to steer, the boat's course to steer. Now, did anybody do the 12 knot version?
Yes.
Okay, so how did you do a 12 knot in this vector? Because the dividers don't move to 12.
Math.
I did it. I set my compass to 6 nautical miles, so I just did it twice. You know,
Okay,
flipped it.
that works. So what I did, I set them both by half. So I set this to 0.75 and then reached out and got 6. I used a 6 here and a 0.75 there. So I cut them both in half. So again, my chart is wobbly and not very good here, but I have my 2. I'll show you on another one, it's more visible. But I have my 2 lines that kind of cross like that, because I did one at 0.75 and 6, and then I did one at the 1.5 and 5. So we've created the triangle, but we still have to fill out this information, right? So so we figured out our course to steer. Which one should I use? 5 or 10 or 12? I'm just gonna use 5 here. So our course to steer for the 5 knot, 5 knot version was 269. That was our course to steer. And then we had to convert that to PSC. So we had our true course to steer was 269. We had a variation of 12 east. So we're going to subtract that 12. And we got 277. And then we used our deviation table to figure out our deviation was 7 degrees west. West, we're going to add. So we get a compass course of 264. Now mine's a little off from the answer there. Did I do something wrong? My math wrong?
Yeah, I think you needed to subtract the 12.
Oh, yeah. 5-7. That looks better, right? That's doing math in your head, right? Never do math in your head.
And I think the 250, 7. I think it's 9 then instead of 7 on the deviation table.
That makes a lot more sense. Okay. adding 9 to this number gives us 66. That makes more sense. Thank you. So we have our course to steer true and our course to steer per compass. Then we're still missing one piece of our triangle here. That is our speed made good. So if we're using the 5 knot one, this was my 5 knots. So I'm going to use this distance to calculate what my speed made good will be. So what did I calculate my speed made good? Was 4.1 nautical miles. Convert that to an hour to get 4.1 knots. I do the common sense check. If I'm chugging along at 5 knots, that makes sense that my speed made good is going to be a lot slower because the current is pushing me in that direction. What else do I want to say? Okay, so then I use my speed made good to help with my ETAs because that's what I'm going to be using. So I get, you know, the whole distance and use that speed made good for my ETA calculation. Then we had our distance go. That was, you know, you just add up all the distances at the end, or the total the course, and then you subtract along the way. So that one's a little straightforward. How'd you guys do on this? Does it make sense?
I did it different.
How did you do it, Milo?
Well, what I did is I drew my track course, and then went 5 knots. I measured out five knots from the start. Then I did my set and drift. So I made the triangle out here, you know, out away from the starting point. So I just
you
measured
measured
out
5 and then did a set and drift.
Yeah, then I did a set and drift, and then I did it, and that gave me my course to steer, but it didn't give me my speed. And I go, oh, that's right. So then I made a set and drift the other way on the other side. Like made another triangle, just continued it down 1.5, and then that gave me like a different course, but that gave me my speed that I would be going, I think. So I came close to your answers, like close enough, like, but they weren't really the exact answers. But now I see that's probably the way you did it is the way I should have done it.
So one of the things that you did, very easy mistake, was you put the 5 miles is what your boat is doing on the made good line.
Yeah.
So we want to keep that made good speed and your boat speed separate on the triangle.
I got you. But I did get my speed made good. Like I got it from my other triangle, you know, and then I gave you my ETA, which was the same.
Okay.
You know.
Yeah.
So that was, I don't know. I mean, that's kind of, I don't know why I did it that way, but I did.
Okay. Well, cool. Let me move the camera here. See my big mess here. Can we see this whole leg? You might be able to. There we go. Okay. Focus that. So for this was waypoint 2 and waypoint 3. So we connect them, we get our course made good. And then here you could see how I did my, here it is. this was my 0.75, so that was half of the set and drift. So then I used 6. I connected, if you could see, this line to 6 nautical miles, and that's how I got my course to steer. So that line right there was 6. Let me show you on the whiteboard. I feel like you can see it better.
Oh, I got it.
Kind of aligned. So to do the 6 or to do the 12 knot version, my divider didn't reach 12, so I could have done it on a maneuvering board and gotten it that way. That was another option. But I decided to do it on the chart. So I cut each value in half. So we had our, let's make our graph here. Course made good, speed made good, course to steer, speed, and set drift. 130, 1.5, 12. What was my course made good on this one? 272. Okay. So that's what I have figured out, but I need to put it on my, to plug this in, my 12 doesn't reach. So I made that 6, and I made my drift 0.75. So I did this 0.75, and then I reached, this is 6 nautical miles to get my course to steer. Other option for the 5 knots was to use the 0.5. So this is 1.5 nautical miles, but it only goes to the 5. This is 5 nautical miles because we're using the whole 5 and 1.5. And because we're going slower, it makes sense that we need a steeper angle. We need to correct more the slower the speed. What kind of questions do you guys have on this?
None. I'll just say I like the radar plotting paper for this.
Okay, yeah.
Which I was confused at first why we were using the radar paper instead of just doing it all on the chart. And then I found with this exercise, it was much easier to do a lot of the work on the radar paper because it's just free of all the clutter, and the measurements are really easy with the way it's set out. And especially if you with the 5 knot sailboat, I thought it was really easy at those speeds.
Yeah, for sure. And you could, zoom in and use that 6 mile scale on the radar plotting sheet. So yeah. So the radar plotting sheets and maneuvering boards are great tools to have. You can do it. You can do it the same thing on the chart, but it is just more clutter, more lines, and you're like, what lines am I looking at? So I get that. I get that. All right.
But Bree, one question though is if you do use the radar plotting sheets, in principle, there's really no need then that you have to go back and apply that to the actual chart.
No, so you could use the radar plotting sheet and you just come up with the information. So when you write it, waypoint 2, on the chart, you could put on this whole leg, you know, course made good is 272. Your course to steer is whatever your course to steer is, 280. True, 285. I'm making this up, PSC, and just have it there so you know. And then you could put also your speed made good will be whatever, 4.1 knots. So you're just kind of putting the information there. So it's a quick visual, but you should also have a voyage plan printed out and nearby the chart as well. Is a good habit to get into. Because sometimes the voyage, you know, as the second mate, who's the navigator on board, on commercial vessels, the voyage changes sometimes. And if you're not up there, you can't switch everything around. So the other mates have to do it, but they have to see your work. They have to see all of the details and all of the work in order to change it around. So you just want to have nothing in your head, right? All down on paper and easily communicated to anyone who's going to be navigating.
Okay. Bree, one other question is there a good rule of thumb to ensure that you're using the right terminology when you're looking at course to steer versus course made good so that those don't get mixed up? Because I almost look at it as course made good, in principle, that's actual, versus course to steer is what you're attempting or your present heading is, correct? Would that be the right way to look at it?
Yes. So your course to steer is what the boat is, what your boat is pointing. Right?
Understand.
So then there's two other, when we look at those terms, right? We have course made good, which is also interchangeable. Some people like to use course over ground. And it kind of depends on what your tool on board has. Does your GPS say CMG or COG? Kind of different GPSs will call it different things, and then you'll just go with whatever that is how I've seen it a lot. And then you have your course to steer. So that's generally our course to steer, right? We have 280 was our course to steer. And then we have our heading, which can, so here we have our course to steer at 280, and that's what we want to be doing. But the heading is what's happening in the moment. So this is kind of your goal, and this is now, what's happening right now. So as you're trying to steer 280, if you're in hand steering, or even if you have an autopilot, you might be doing something like that. You know, it might not be exactly steady. So so those try to be the same, but so when I say course to steer, that's kind of the average along the whole way of what you're trying to steer, but the heading can change momentarily.
Okay, yep. Thank you.
Yeah. Okay.
Hey, Bree, is course over ground and course made good interchangeable? I was told they are not.
Yes, well, I would say you're probably told by someone who not, because they were doing bottom tracking. And but in open ocean or congested waters, I would just use them interchangeably.
Okay.
You anywhere here, you're not going to be able to do bottom tracking because it's so deep.
That makes sense.
If you're in maybe like inside or Dana Point Harbor or something where it's much shallower, you can do that bottom tracking. But not in these waters, at least.
Okay, that makes sense. Thank you.
Okay. Okay. I think I'm gonna move on to our tide question. Are you guys okay with the chart? Okay, let's do our tide question. So hopefully, did anybody do any of the Murphy's questions? The practice from last week? From 1983 or whatever?
Did not have time.
Okay.
No, I didn't.
Okay. That's all right. I was just curious. Okay, so our tide question, we had, this was working a second ago. Santa Barbara on April 21st at 13:45. What is the tide? So, I need to get my paper out. First, I will set up my my table. I have a question. Did anybody is anyone doing tides a different way than I am? YouTube a different version that they like better? I just like getting students' input. Okay. Okay. So we have our reference station, our differences, and then what's happening at Santa Barbara. On the differences page, we have high water, low water, high water, low water. So I'm just going to copy that. And then I'm going to find Santa Barbara, which is 459. And I'm going to copy down those corrections. Just going to write that. So we had a plus 23, a plus 21, multiplied by 0.98, and a multiplied by 1.04. Then we follow this up until we get a reference station. Los Angeles, page 76 is our reference station. So I'll put that in, LA. And we are looking for April. This is really far away. Okay. So we were looking for April 21st at 13:45. So the times that sandwich are 10:46 and 16:01. And I'm just doing a mental check. If I add an hour, that'll still be sandwiching. So we're good to go. So the first one, 10:46, I'm gonna write this here. So it had 10:46 at 4.1, 16:01 at 1.4, 22:15, 5.7, and 29 is negative 0.8. So that's what it looked like on the 21st. And I want to sandwich this time. So I'm going to pick these, and I'm going to note which one's high water and low water. So this one's the bigger. So this is high water, and this is low water. So now when I plug this in, high water was at 1046 at 4.1 feet. Low water was at 1601 at 1.4 feet. So now I have kind of my equation here. And I am going to apply these differences. So I'm adding here. And 9, 0, 1109. And that would be 1622. I'm gonna need a calculator for this. Oh, my calculator's real weird today. 4.1. Can't even do it. I'm looking at the answer here. 4.0.
And 1.45.
And 1.45. So we'll just call that 1.5. I'm also noting that it is daylight savings time in April, and this is on our Pacific Standard Time. So we need to add that hour to our times to get what's happening Santa Barbara. So we have 1209 and 1722, and then those heights are the same, unchanged. So this is kind of our snapshot, and it's a little messy, so I always like to rewrite it, and then it goes into my little brackets. So I have 1209. I'm gonna put it over here. 1209, the tide is 4.0 feet in Santa Barbara. At 1722, the tide is 1.5 feet. So that's what my calculations gave me. And I want to know, what is the tide at 1345? So now I get to go to my chart 2. What chart is it? Not chart. Chart 3. I need to find my TNT, my range to get my correction. Oh man. Hold on 1 second. Okay, can you guys still hear me? Okay, good. It's telling me my internet's unstable, but I got the little booster thing, so hopefully it's still good. Okay, back to here. So we need a duration. That's going to be the big one on this side. Range is going to be the big one on this side. And then we need time to the nearest. So is my 1345 nearest to 1209 or 1722? This one's pretty easy, 1209. So that means I'll be applying my correction to that high tide. So we need to do some math. We have 3, 13, and 5. So we have 5, 13. Here we have 1345 minus 1209 gives me 36 and 1. And then I have 4.0 minus 1.5 gives me 2.5. So I need to go to table 3 to find my correction to height. So let's do this together. Our duration was 513. So I'm going to use closest to 520. So I'm going to use the 520 line. And then as I go across, I'm looking for 136. Something as close as I can get to 136. And we have one at 136. Get my other one here. So now I know I'm going to be somewhere along this column. I'm going to be falling into this column. So I go back to my range, and I see my range is 2.5. So my correction, I know it's hard for you guys to see, is going to be 0.5 for my correction. So do I need to add it or subtract it? I need it to stay within this sandwich or this bracket here. So I'm going to be subtracting that. And I get a tide of 3.5. So all of that work, and we figured out our tide, 3.5. You guys remember that? Did it come back to you? Okay. All right. Any questions on the tide calculation? Okay. All right. Let's do a rule of 12s. Where's the top of this? Okay. So we have, let's see if I can draw a bell graph. There we go. We have a, what does it tell? Where is it? A high water at 12:15 of 6 feet. Oh. And then we have a low water at 18:15 at -3 feet. So we have kind of this 0 line in here. And this is our tide. So we're working with the positives and negatives on this. And we know if we divide this up by 6, 1, 2, 3, 4, 5, 6. With the rule of 12, we have the numbers of 1, 2, 3, 3, 2, 1. And that's how it changes. If 1, 3, 3, 2, 1, those are 12ths. So I guess I'm just kind of illustrating it before I actually do the work. So our first step to do this problem is to figure out the range. So then I can figure out what 1/12, okay, I can't even write 12. Sorry. 1/12, 2/12, and 3/12 are. So the range is going to be total from 6 feet to -3 feet. So it's going to fall to 0, and then it's going to fall an additional 3 feet. So my range is going to be 9 feet. That's my range. So then if I get 12ths of 9 feet, I get 3/4, which I guess I did it in decimals. We can do it in decimals. 0.75. 2 of those is going to be 1.5, and 3 of those is going to be 2.25. So those are my 12ths. If I do this on the hours, try another one. 12:15, and then I'll just add an hour. Okay, so I know at 12:15 the tide was 6 feet and it's falling. I know it's going down. The first hour, I'll put it next to it here. We have 1, 2, 3, 3, 2, 1. So that means it's 1 is 0.75, 1.5, 2.25, 2.25, 1.5, and 0.75. So when I start subtracting these, so 6 minus 7.5 gives me 5.25. 5.25 minus 1.5 gives me 3.75. 3.75 minus my 2.25 gives me 1.5. 1.5 minus 2 is going to give me into the negatives. Now I'm going negatives. Negative 0.75. 0.75 minus my 1.5 gives me negative 2.25. Minus my 7.5 gives me -3, and that is what I'm ending with. So now I have a little tide table for this specific area. And it asked me, what is the tide at 16:15? Now, did anybody do it without doing all of this fancy work? Okay. So without doing the fancy work, you could, if we're looking for, it's 12:15. Let me get a different color. 12:15, and I am looking for 16:15. That's what the question was. So I have a 4-hour difference. So that is going to have a 1, 2, 3, and 3 change. Does that make sense? So if I which is essentially 9/12. So if I get 9/12 of my 9 feet, I can't even do that in my head. I'm going to be subtracting 5.75 from my 6. No, I'm going to be subtracting 6.75. Yeah, that makes more sense. Yeah, okay. 6.75. So you get negative 0.75 feet. Or you can do it this way. Some people do the mental math. I don't know.
Yeah, if you just take 1/12, 0.75 and multiply it by 9, you're going to get the right answer. Subtract 6.75.
There we go.
Nice and easy.
So you can do a quick one if you're looking for a specific time, but either way that works. Okay. What about our multiple choice questions? Fill in the blank. This is testing our overall knowledge, right? So LOP, and they were very creative in their multiple choices. I hope no one said D. An LOP is a line along which an observer is located. So infinite possibilities of where an observer is located. A bearing is all of these expressed as a 3-digit number because it can be 0 to 359. It can be expressed in compass, magnetic, or true. And it's a horizontal measurement from an object from the observer's position. So the horizontal measurement is from north, right? We always have our bearings from north, whether it's compass north, magnetic north, or true north, whatever it is, that 0 is north, and then you have that horizontal measurement to get the bearing. A line connecting all possible locations at any given time is your LOP. Relative bearing. Now, relative bearing, our reference point is the bow of the vessel. So what did they tell us? There we go. It's measured relative to the bow of the boat and clockwise. So clockwise, just like the other compass of north, compass, magnetic, true, whatever it is, we always go clockwise. So you're just changing that reference point, if it's relative or if it's compass, magnetic, true, whatever it is. Okay, the main advantage of using a visual range to take a bearing is, I love my visual ranges because you don't need a tool. There's no tools needed. You just need 2 objects that are on the chart to be in line with one another. So yeah, that's that in line with one another. It could be 2 points of land. It could be a buoy and a point of land. Could be 2 buoys. Could be any 2 things, but they have to be on the chart, and you don't need any compass or radar or any sort of tool to measure it. So I like that one. Okay, fill in the blanks. The best angle of intersection between 2 bearing fixes is 90. What would it be if it is 3 bearings?
60.
60 or 120, which would be double that. MLLW is an abbreviation for mean lower low water. When we're talking about current, set is the direction towards, and drift is the speed or velocity. When correcting compass, what acronym do we use? TVMDC or CDMVT, whatever one you use. What is the formula for calculating speed, distance, and time? That's our 60D street. Remember back when we just learned 60D street and it was a lot of work? Now look where you guys are. You've come so far. All right. Variation is determined by what?
I put the closest compass rose.
That's true. Yes, that's where you find it. But it is it's how it's created, why it's there is the geographic position or your location. Where deviation can be affected by your boat's magnetic pulls or magnetism. So just what the two differences between variation and deviation. But yes, your deviation is then determined by your deviation table. Okay, how do you determine what the current is? What are our two possible ways of determining current? We have getting the difference between a DR and an actual position. And then we have calculating using the navigation pubs, whether it's the tide tables, the website, whatever other tool is out there. They're using the navigation pubs. What is the difference between tide and current? I hope you all can remember this one and not say that the tide is pushing me to the west. It's the current that is pushing you to the west. So tide is that vertical movement of water, where current is the horizontal movement of water. Okay. That's any questions? That was kind of a little review.
Well, I'll just have one.
Yeah.
Like, I was number 3, a line connecting all possible positions of your vessel at any given time. I tried to do this without the answers, and I looked at that and I didn't know what they were asking. I was like, what? So it was just kind of maybe just me, but it just seems kind of like I didn't really understand what the question was asking.
Okay, I get that. Yeah, a line connecting all possible. So it's kind of looking at the question backwards of what is a line of position? It's a line connecting all possible positions of your vessel at any given time. I can see how that would be confusing. Okay, I'll note that. Yeah.
Can you send me the answer key for the final exam plotting exercise?
Yes.
Thank you. I just want to check the rest of my answers and see if I did them right. Thank you.
Yes. Other than that, let's take a 10-minute break before we dive into the PowerPoint. Or let me know if you have any questions, but let's take a 10-minute break. We'll come back at 7:40. Well, let's get back to it. We'll dive in here. This looks weird. Just bring it up. There we go. Okay, so we are going to be talking about GPS. I'm not an expert in GPS, by the way, but it's good to have a basic understanding of where your information is coming from so that you can better understand errors or warnings or other things that come up so you can verify your position one way or another. So even though I would say most people heavily rely on GPS or the little blue dot on their phone whatever it is, it's always good to verify your position. Verify it with radar, verify it with visual range, verify it with just a piece, with another instrument, a depth sounder, whatever, any sort of instrument. It's always good to be verifying all of your instruments so you can catch when one goes wrong. So hopefully if one starts having errors, it will alarm for you, but you do want to verify it all. So let's dive into GPS. So basic GPS overview is I'll go to this slide. We have 24 satellites, 3 of them are spares, and they are all rotating around the Earth. The United States government operates them, maintains them, so they're all rotating around, and we're basically using those satellites as like an aid to navigation, essentially. We're getting a range from each satellite, and we basically need 3 or 4 ranges from 4 different satellites. So because there's so many of them all orbiting around the Earth, that's where we get, a good spread where, if we had 2 aids to navigation, we want them 90 degrees apart, or 3, we want them 60 or 120, right? For GPS, it's kind of the same, that same concept there. So we're just getting the distances from these, there we go. I can go back to those other slides, but when we get a distance from a satellite, just like when we get a distance from an aid to navigation, we get this arc. So let's say we got a distance from Catalina West End Light. We would draw it as an arc of 2 miles around. We can be anywhere on that 2 mile circle around East End Island, where part of that circle is going to be on land, so we know we can't be there. So we need another piece of information, a bearing or something else, to help us tell us. Where when we look at what the satellite gives us as our LOP, if you will, the LOP is a whole sphere around that satellite. So the satellite is in orbit, and when we get a distance, it's just like, I want to say it's just like radar, but I know I didn't teach radar to you guys. A time that receiver on your boat sends out a signal, a time signal, that is then received by the satellite, or it's sent out by the satellite, then received by the receiver. And it's the time difference that it takes gives you the speed, or gives you the distance, essentially, with our 60D street kind of thing. So we get this distance around the satellite, and then we get a distance around another satellite, and then a distance around another satellite. And you get this area that you could possibly be with 3 or 4 satellite spheres. So it's, instead of 2-dimensional on the chart, this is 3-dimensional spheres. I wish I had a sphere. But only one of those can be on the Earth's surface. So one of those, just like we could narrow down on the chart that we're not on the land, we're someplace else, we can eliminate some of the other possibilities. So of course, if you have more and more satellites, fixes, so it's typically 3 or 4 with the geometry, will give you 2 points, and one of those points will be on land, one of them won't. If you are doing air navigating or flying, I think you have to calculate something else. I think one of you guys is a pilot. I'm not sure.
I am. Yeah. Yeah, you could do it off of 3 satellites. You could do it where you don't have to have the 2 errors or 2 possible locations. It's just a matter of what kind of radar lock you have to the satellite, because what the satellite is putting out is just the exact time code. It doesn't do anything else. I mean, it doesn't receive any kind of signal from you. It's just pushing out time code continuously.
Yes, and the satellite is keeping track of the other satellites. It has a little.
Yes, no. It does to a certain extent, but that's only for its maneuvering capabilities. So the satellites are in, they're not in geosynchronous orbit. They are in an orbit where they're going to rise and fall once a day.
Yep.
But you're going to wind up always being in sight, no matter where you are on the Earth, be it above the Earth or on the Earth, of being in view of at least 6 satellites at the same time. So you're guaranteed to at least capture 3, and that's how it works.
There we go. Here's another image, a little bit blurry, of that sphere as an LOP instead of an arc or a line. As we get these spheres, and the center of that sphere is the satellite that it's getting a distance from using that time signal. Accuracy, when we're talking about regular GPS, the accuracy is about 15 to 50 meters. We can lose our accuracy if one of the satellites is not orbiting correctly, if we have poor geometry. Like Stephen was saying, there is more, you should be able to see, what did you say, 6 or more satellites on the horizon at a time. So you should be able to get some geometry, a good fix. But sometimes you don't, depending on where you are and where the satellites are. Antenna position, you don't want to use your antenna inside the cabin, right? That's where your receiver is. But if you have a receiver and an antenna, I can't say it, you want the antenna posted outside and hopefully high. But a lot of times, a lot of recreational boaters will just have a handheld GPS where the satellite, the interface, the receiver, everything's in one little unit, if you will. So you always want to go outside to use your handheld GPS. And if you have a handheld GPS, this happens frequently if you're flying around. If you turned it off more than 300 miles past your last position, you need to manually input where you are so that it can correctly find the satellites and get your correct position. So if you're flying to Europe or something and you had your handheld GPS, you used it in Long Beach, and then you turned it on in Greece or wherever, you want to manually input your position, and then it will fine tune it. So it doesn't have to be your exact position, but generally speaking, where it is, hopefully within 300 miles, and then it will fine tune so it knows what part of the earth you are in. Warning messages. If any of you have used a GPS before, I'm sure you have had warning messages. Beep, 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 beep. You get this annoying beep, and then it's just silence, silence. Turn the volume down on that. Don't even worry about that. But you really do want to listen to those beeps or those warnings that your instruments are giving you, whether it's your Doppler, your fathometer, whatever it is. You want to listen to those warnings. They're there for a reason. If you don't know what it is warning you about, look it up. A lot of times, I'm going to show you actually. I was looking up the manual. A lot of times manuals, operator manuals, you want an operator manual for all of your nav tools, have their terms, their terminology, and it will literally tell you, what each acronym and what each alarm is meaning. And then if you deep dive into it, it'll tell you how to fix it. So definitely be familiar with those operating manuals. Trying to find one that I was taking. Anyways, okay. Stop share. Okay. But to be familiar with some of what they mean, we have our almanac verify, meaning we're missing information on other satellites. So the almanac is the other satellites. So you're still good. You don't have to turn it off, but you're missing information on other satellites that you're not currently using. Now in 2D and 3D, doesn't make sense to me, but 2D is going to be your 3 satellite fix. Your 3D is going to be your 4 satellite fix.
Yeah, the difference between the two, the 3 satellite fix is enough to establish 2 potential points inside of either the Earth, on the Earth or above it. 3D is enough to satisfy that there's only 1 point.
There we go. I'm gonna leave for a second. My dog is going crazy outside and my husband is not here. Stand by.
Hey, Teresa, do we have any like Tylenol PM or would you put it off for me? Thank you. All right.
Sorry about that. Okay. So Stephen was helping us out here. He definitely knows more about GPS than I do. All right. Got a warning. Okay, this is some example images of what you can actually see which satellites you are using and which satellites they're searching for or they're tracking or isn't getting, gives you that unhealthy signal. So they have different colors and you can see which ones you're observing. So it's good to look at or to try to, look at your manual and see what it's doing so you're aware of it. Then we have DGPS. Excuse me. So DGPS is our differential GPS, and we have one more component in there. The component that we have is a known position. So there's a DGPS land station that it knows where it is. It's set in land, right? It's on land. I'm pretty sure there's one if you drive down to Carlsbad or down to San Diego, you see it past the past Camp Pendleton. It's kind of like this white little tower thing. Anyways, that is a land station, and the satellites are still, it's kind of acting as a receiver. So the satellite can send out its signal, the land station receives it, and it can calculate any error. It can say, oh, this was a little bit of error in that satellite. That calculation, that time calculation of how long it took for me to receive it, I'm going to send that correction back to the satellite. So when it's receiving signals from all of these other boats, it can apply that correction. So essentially, you're getting a corrected signal because it has these land or these fixed receivers. And it is much more accurate. We get 15 meters to 10 centimeters accurate, which is incredibly accurate. Here is a map of our DGPS stations. We have some land stations, but we have a lot of our coastal stations there. So just to keep that in mind, I'm going to say most of your GPSs are can use DGPS. So let's look at some examples of the units. So again, you can have a whole interface that is color-coded and high-tech and touch screen, or you can have one where you have to push a zillion buttons, or you could have just a little handheld one. There's zillions of types of GPS out there. So I'm not going to say this is what your GPS is going to look like, because there's a million GPSs types. But we have some vocab that you will find on most of them. So we have our waypoint. So a waypoint is just that that stored position that we use for navigation. So that's informing a route or creating your track line, right? When we were doing our voyage plan earlier, we had waypoint 1, waypoint 2, waypoint 3, and we could save those waypoints and then call on them later. So I always like to name the waypoints, not waypoint 1, waypoint 2, but name it waypoint NWP because it's the NWP buoy, or waypoint Avalon, waypoint buoy J, or whatever it is. That way, it's not actually buoy J, but it can be the turn that we always make at buoy J, or whatever it is. So you want to be able to store your waypoints, which makes it so much easier when you're trying to create those routes again. You don't have to re-input all of your waypoints. Nowadays, most of your GPSs are going to have what they call auto routing. So our next topic here is a route. So your waypoints all string together to create a route. Now, most of GPSs nowadays, you can say, maybe you're hanging out over at Two Harbors and you want to go to Avalon, you can say, route me to Avalon, and it will route a safe, give you a safe route with lots of waypoints, not lots, but with as many waypoints as you need to get to Avalon. Of course, you put in your parameters beforehand. This is my vessel's draft. This is, my rate of turn. You don't want to make very sharp turns if you can't. But yeah, most places will have this, or GPSs will have this auto routing. So you don't necessarily have to store all your waypoints, but back when I was doing it, we had to store all of our waypoints, and it was a big pain in the butt. Okay, then we have distance. So that's going to be the distance to whatever is selected. So your GPS gives you the actual position, the lat and long is just one little portion of what your GPS gives you. It's going to be when it has a waypoint or something that it's headed towards, meaning it's not headed towards it. It's just has a goal in mind of where they want to go. That is not an actual buoy or anything. It's just a created waypoint, a made up position in your that you've inputted. So that distance is to that actual waypoint. The distance to go is to the end of the route, or the end of to the final waypoint, the end of the route. So when you get bearing, that is going to be our bearing to the waypoint. So what we see a lot on our GPS is a bearing and a distance. That bearing and that distance is to the next waypoint, is to the waypoint that you are headed towards. So I'm going to skip ahead here. Here we go. I was like, did it say it? Not really. On this one, we have a bearing to the waypoint of 060, and our range is 0.16 miles. So I'm going to go back to this page. I don't know. I use bearing and distance a lot in my navigating. So I could say, okay, how long do I need to go until the next turn? Is it a short distance, a long distance? And that bearing helps you. Am I pointed towards my goal, or am I, cutting it short? That bearing to the waypoint. So it's not a bearing to an age navigation. You can't use this bearing for, navigation purposes, because it's just bearing to a made up created spot, like that waypoint 2 we created. It was just a spot that was 5 miles off of Long Point.
And Bree, would the bearing be relative, or would it be true?
It would not be relative. It would be true.
All right. So when we're looking at GPS and it says the waypoint is bearing 60, if we looked at a chart, we could look at 60 degrees on the chart true, and that would be the direction of that waypoint.
Yes.
From the boat. Okay.
Yes.
Great. Thank you.
So essentially what you would do is the waypoint would be on your chart, and you would see 60 degrees towards that waypoint, and you are most likely somewhere along that waypoint, that line, because you want to be headed towards your waypoint. Hopefully you're headed towards your waypoint. We have then our course over ground or speed over ground. Course made good, speed made good. And then we have our XTE, that's our cross track error. So that tells us if we're to the left or right of track. We're all going to have different comfort zones on this, but it really helps you to, if you're in autopilot, click it to the right a couple times, click it to the left a couple times. You just want to stay on the highway. I'm going to go back to my pictures. So if I look at this guy down here, this is giving us a visual of cross-track error. So my boat is exactly on my course line, so I have 0 cross-track error. But if I was over here, I would just be, to the right of track, or I'd be to the left of track. And I've created a highway. I've created a 0.05 nautical mile limit. So that's kind of my road that I can cruise on, especially if I'm in hand steering or something. But it will tell me if I get past that. So that's where I have my where was I? Cross-track error, and then your cross-track error limits or alarms. So you could be you'd get a cross-track error alarm if it was past that point that you've inputted, whether it's a half mile, 0.05 miles, whatever, whatever it is. Then we have time to the waypoint. This one is a great tool. I would say especially for communicating with other vessels. Oh, I'm going to be at that buoy in 20 minutes or 2 hours, whatever it is. Instead of having to do that 60D Street, let me figure out where I am. That time to the waypoint is a great tool. Then we have our man overboard button. A lot of people are afraid of this button. Sometimes it's covered in plexiglass. Sometimes, most of the time, it's red and it has a big man overboard on it. That button does not do anything. It doesn't call the Coast Guard. It doesn't ring alarms. It does not do anything except for save your current position right now. So fishermen use it. Hey, I dropped a crab pot, man overboard. Now I know where I can come back to it. Hey, I liked this view, man overboard. It's just a quick save your position with one click. So when I think one of you guys was doing a GPS or GMDSS or radio class next, but they talk about that one click where you can get a task done in just one click of a button. That's what the man overboard button is. It saves the position and it puts it on the display with just one click. You don't have to go to a menu, save my position, I dropped a crab pot over here. It's just a one click save your position button. It does not call the authorities. So don't push it and expect somebody to come find you. Okay. We have ECDIS versus electronic plotters. So your GPS unit can just be a unit, whether it's handheld or gives you that little display with the symbols and letters and numbers, or it can be a very pretty chart picture, electronic plotter, or if it's highly integrated, you could have an actual ECDIS. But I guess what I'm saying is the GPS is just one input into it. You want to use all of your tools that are available to you. So you can overlay certain things. You can overlay the radar. You can overlay the GPS is inputting to the chart plotter. If your GPS has a bunch of errors, then your electronic chart plotter is going to have a bunch of errors. So be careful of that. Bad info in is bad info out. So yeah, you're like, oh great, that GPS unit is out, but look at my pretty chart plotter. It tells me I'm in safe water. If that chart plotter is dependent on the GPS and you don't have any other redundancy, then the pretty picture, even though it's not giving you warnings, is not good information. So just keep that in mind. Very common human error. It's very easy to punch in the wrong numbers. With any GPS unit or electronic navigation unit, they all work in different ways. A lot of them are touchscreen now. Some of them have dials. Some of them have a trackball. Some of them have an actual mouse. Some of them have, 3 buttons to click or just a right click, left click. There are so many different ways. You got to get used to the one that you're using on your boat. If you don't have a boat, most of us don't, and you're chartering a boat, you want to familiarize yourself with those units and those operating manuals and just practice punching in some waypoints, practice creating a route, practice auto routing, just so you can get a feel for how to maneuver through the menus. Just maneuvering through the menus of all of these electronic navigation tools is a challenge in itself. So yeah, I'm just gonna say you gotta get your hands on it, and don't be afraid to push buttons and change settings, change things. The more you change it and experience it, the more useful that tool will be to you, because the more comfortable you are with it. So a lot of people are like, oh, I'm just going to leave it. I don't want to mess it up. I don't want to touch it. But it can give you so much information. You want to be comfortable with it. Okay. Excuse me. This is an example of the routes. You can save your routes. So, you know, based out of Newport, this is my Newport to Avalon. This is my Newport to Dana Point. This is my Newport to Carlsbad. It's my Newport to Santa Barbara, wherever it is. You can save all your routes so you don't have to punch them in all over again. And you can save all your waypoints. Once you have your route plan, it is very similar to the one that you've just calculated on the chart. So sometimes your route plan, if it's, I guess on a small boat, you wouldn't have a printer, but on my bridges, we always had printers, so you could print it out and use that as a reference, and it was a great tool. But you can double check your information that you've plotted on the chart. And this, from an experienced mariner, I did this 100 times, where I plotted it on the chart, created my little voyage plan, just like we did. And then I bring it up on the route planner and it's off. And I'm like, what the heck? But I just typed in a waypoint, you know, inversed one of the numbers in the latitude and longitude or something, and you get a whole new you know, bearing, distance, and ETA of where you're going. So it's always, you always want to double check and verify. So maybe I'm old school, but I like to put it on the paper and then put it on the electronic tools and then verify everything together. You can use those, what I also did is use electronic plotters to create those waypoints. You know, it's easy to move around a waypoint digitally. Then I'd write that waypoint in and then put it on the chart. Just because I like the clean numbers, like let's just call it 0.5 or 0.0, instead of, if you just pick a spot and get the latitude and longitude, you might have lots of little numbers past the decimal point. Maybe that's my OCD. I don't know. Okay, let's move on. Okay, electronic plotters can have all sorts of different information displayed. So depending on what you want and what you're doing, you can customize your display. So your basic panel, your basic display panel is just the electronic chart itself. 2 is a chart and a radar. Sometimes you could overlay that radar on top of the chart, so it shows as one panel, but it is 2 separate things. And then you could have the data. I like looking at the numbers. You know, what's your speed over ground? What's your bearing to the next waypoint? What's your range? What's your course made good? All those things. So cross-track error, it's just good to have those numbers, or I like to have those numbers, but everybody is different depending on what they're doing. The 4 panel, they have a little dial thing. you know, lots of different setups, I guess you can create. Okay, so let's talk about what all of these numbers are. So we'll go with the big one here. We have our position, right? Our position in degrees, and then minutes and tenths, hundredths of a minute. So we have our north or west, there are degrees, that's our position. We have our speed over ground and our course over ground. And all of these have a course over ground of magnetic. And I don't know why that is magnetic, but that's just noted. Then they have the time and the date. So this one's pretty simple, pretty, you know, nothing fancy, just your basic information of what you want. But if you want a little bit more information, we have the 003 there is indicating the waypoint that it is going to, the waypoint that is selected. So it is headed to waypoint 3. Course to steer, it's giving you a course to steer, which would essentially be the bearing. Distance to destination, that's going to be the final destination. This is going to be distance to waypoint. This is going to be your cross-track error, your speed over ground, and your course over ground. And then here they give you a heading. I'm pretty sure that's heading. It's hard to tell. But it says our heading is 153. So we are not headed anywhere near our course to steer. So I don't know what we're doing here. But it wants us to set a heading of 320. I don't know what we're doing in there. We got some major differences.
Isn't 153 also the course over ground? Could that be what it's talking about?
Course over ground and heading. Oh, it does say course over ground was 153. But course over ground and heading are two very different things. Well, not very different, but
Would it be possibly representing the end of the path from a waypoint to another, and they're now switching direction to a new waypoint?
Well, it says distance to the waypoint is 86 meters.
Yeah, that's weird.
You know what I think it is? I think it might be like a I feel like it's a reciprocal. 320 and 150 are reciprocals. So it's like it's going astern, which isn't crazy. Like on a research vessel or a offshore supply vessel, those types of vessels, tugs can be facing all sorts of different ways. Whether they're going 20 knots, I don't think that's, I don't know. This is just a picture. Okay, I'm gonna move on. We have name of the waypoint, distance to destination, bearing to the waypoint, speed over ground, course over ground, and then we have this visual for our cross-track error. So I liked the cross-track error one. This is another steering display for your GPS unit. It gives you an actual heading. I'm pretty sure this is heading. Little compass display. Oh, it's bearing. A bearing display. So that's kind of nice. Depending if you are used to steering the vessel by a compass and you're used to seeing that compass move, or you're used to just seeing the digital number change, that's kind of like just what your experience is or what you like to see visually. so it can give it to you in that digital format, that actual compass turning, if that's how you like to steer from. Then we have our bearing and our range. So again, our bearing and our course over ground are so completely off. These are really bad examples. Yeah, you want your bearing and your course over ground to be the same. And that means you're on track, or that means you're headed directly for your waypoint, which is what you want. I'll have to come up with some actual real life pictures instead of these internet Google images. I apologize for that. Let's look at another one. Oh, this is another cross-track error. Kind of, are you on the highway or not on the highway? So that's another visual. This one makes a little more sense. We have our bearing to the waypoint and our course over ground the same. So that is great. We have our range and our speed over ground. So yeah, you want that bearing and that course over ground to be the same. Okay, now we're going to talk a little bit about navigation at night. Does anybody have any comments about GPS or your guys' own experiences with GPS on board? Have any of you created routes and plugged stuff in?
I have a Navionics on my iPhone, but I don't really know how to use it very well. But I've tried a few times.
Okay.
So and it does automatic tracks. Like if you want to go from Avalon to like Twin Harbors or something, it'll give you an automatic track. So I've done that before, but I really don't know how to use it. You teach a class on how to use it?
There is electronic navigation class, but part of it is in person, and I am choosing not to do in-person classes right now. So there is electronic navigation class, but I'm not teaching it. I don't know when it is.
I've got a question, Bree.
Yeah.
Sometimes when I'm out sailing, I'll hear, sometimes it'll be an SOS call from another boat, or it'll be typically the Navy saying they're doing live fire exercises, and they'll give their location. I'm just wondering how you would tell how far away from you. I figure with the latitude, you could just kind of mathematically, you could just do the math, but with the, I mean, how would you, if somebody gave you a location and you're out, how could you tell like quickly how far away they were and which?
So without messing up your route or anything, if you had an electronic plotter of sorts, you could just say, I would just click on the screen and create a new waypoint, and then you edit that waypoint to that exact, put in the numbers, exact what you heard on the radio.
Yeah.
And then it will move it to wherever it is. And then with your cursor, you can easily get a bearing and distance, range and bearing, to wherever it is. If you just have a unit that's like this, if you input a new waypoint, the current waypoint that you're at is, going to be lost, and then you're acquired on this other one. So it's a little bit harder to, I don't know, multitask on this type of interface than it would be on like an electronic plotter itself. You can do different things at once. You can be voyage planning for, your trip to Mexico when you're on track to go to Avalon from, Newport or something. So you can definitely do multitasking on the electronic plotters.
Well, I have a question. Do any of the electronic plotters pick up signals like that and automatically place that information?
I'm gonna say no, because typically that military information is not, well, I want to say it's not digitalized, but sometimes it is. But I don't know. I haven't had any sort of navigation tool that is also integrated into a communications tool. In my experience, those were always separate, the navigation and comms. But I'm not saying it's impossible.
Yeah, I mean, I could use AI if I have to in order to pick it off the airwaves and just get the data as they're speaking. But that's no problem. It sounds like that's an interesting product I could make. Cool.
Yeah.
Bree, is there a good rule of thumb that you use for taking and comparing the information from the electronic format and then going back to your actual course chart to verify you're on course in the event that you have a backup for loss of electronics?
So what was your question in there? You're comparing
Do you
your
have, do you have like a good rule of thumb for frequency that you'd use to go back and forth between your voyage plan on chart compared to the electronics?
No, I don't have. I guess what I would say is it kind of depends on where you are. If you're in congested waters and if you're going back to the chart or going down below to plot something on the chart and losing all of your situational awareness and you're in congested waters and there's traffic and things, then you're probably not going to be plotting your position on the chart as frequently and depending more and more on that electronic plotter. So it's kind of that balance of, they call it bridge team management, or you know, that balance of finding, yes, I want to plot things on the chart to verify that all of these are correct, where in modern times ships, at least commercial vessels, are all going paperless and they don't even have paper charts that they are plotting on. But I would say if you plot something on the chart, it should be easily verifiable by, as soon as you plot it on the chart, you can quickly say, oh yeah, my bearing and my range to the waypoint is correct. Check, that's verified. So what I think would be the time consuming part is actually plotting it on paper. But anytime you plot it on paper, you should easily be able to look at the numbers on your digital screens to verify it, to say everything checks, or something says I'm really off, I need to find another piece of information to double check this or get a new position. Does that kind of answer your question?
Yes. One other question I wanted to ask is, could you also use the GPS then to create a deviation table for your compass? If
you would be comparing your deviation table is based on that magnetic compass, right?
Correct.
So you need that magnetic compass, and then you have the GPS unit. So you're comparing, you know, both of those. So I guess I would say yes, you could try that.
Okay, thank you.
Yeah. Okay.
Just a FYI, that's going to heavily depend upon what the weather is currently doing. Because remember, the GPS, they are just radar waves. They're literally radio waves that are coming down from space. Actually, I think it's around 20,000 kilometers above the Earth's surface for each one of those satellites. So if there's a large amount of things around that can interfere with radio waves, that's where that error comes from in the plot. they're highly accurate if there's less interference. So you could wind up with incorrect data from where you think it's pointing. I would say probably if you have 3 satellites, I would say you're probably within about 3 to 4 azimuth of error on your direction, potentially.
All right, cool. Okay, so now we're going to dive into navigation at night. We don't have too much on this, but kind of some rules of thumb. Have any of you guys been out on a boat at night or in the fog?
I have.
It has been crazy foggy here, at least Long Beach, the last couple mornings. So fog is definitely a real thing. I'm sure it's foggy wherever you guys are too. But it can be very disorienting if you're in the fog or at night, and things can be very, very disorienting. One of the main things for night navigation is the background lights. It's very hard to tell if a distance, if it's just one single light. So there can be a brighter light that is further away than a dim light that is much, much closer, but that can play, I don't know, optical illusions in your mind about what's close and what's not, so that seeing those distances can be very disorienting at night. But when you're navigating, if you're navigating using your visual, visual bearings with your aids to navigation, the thing you want to do is correctly identify that aid to navigation. So your lights will have your lights and buoys, anything that is lit up that is used for navigation should have a light characteristic. So you always want to double check that light characteristic. Remember from Coastal Nav 1, we had the light list, which is a list of all the lights you're going to see as you're approaching a harbor or coming into a bay or wherever. That has all the light characteristics on it. So that's a great tool to use to double check what you are seeing and what you are getting your bearing off of is what you are getting you're plotting your bearing on your chart itself. So correctly identifying those aids to navigation is super important. Also to keep in mind is collision avoidance. So I'm going to skip ahead here. Oops. So when we are talking about nav lights or lights that are on your boat, we have green on the starboard side and red is on the port side. And then we have a white stern light. You also can have a white masthead, whether it be all around or just that 1125 to 1125. So hopefully that's not new information to you guys, but the green side is going to be your starboard side. So depending on what lights you are looking at, so here's a boat here and we see both the green and the red and the white. That means that boat is head on, is pointed directly at us. If we just see a white and a red, we're only seeing the port side. If we just see a green and a white, we're only seeing the starboard side. If we just see a white, we're only seeing the stern. So it gives us that aspect for collision avoidance of what side of the ship are we seeing, because we can't see the ship itself. We can just see their lights, and those lights tell us so much information. The light tells us basically in a crossing, or it tells us, who has the right of way, who is the burden vessel. If you guys took the rules of the road, stand on, give way. We have different types of responsibilities in a risk of collision situation. If you see a green light only, that means you have the go ahead. Green means go. You can continue on with your course and speed. If you see a red light only, that means stop. You are the burdened vessel and you have to give way to the other vessel. If you see both, that means both of you need to give way. That's a head-on situation and you both need to turn. This is not a head-on situation, so that's not always true. I know I just said that, but right, we see both of his, but he's looking to the side of us. So essentially, he needs to keep out of the way of us if we are both moving. I don't really know if we're both moving, but anyways. So we always want to follow our collision avoidance rules of the road. Keep those in mind. You want to have a good lookout. It is harder to see at night. Even though there's, less things out there, it is harder to see. So you want to turn down the cabin lights and not have a million lights on, because that helps your night vision and helps with that, how I was saying, it's so disorienting on background lights or vessels or aids navigation on what's what. The more you are watching the lights on the horizon and watching what's going on and not being distracted by the bright lights on your vessel, then you have better situational awareness of what's going on outside your vessel. This makes me laugh when I think about the Newport Christmas boat parade, because there's a zillion lights going on and everybody's bumping into each other. But that is definitely a nighttime navigation and people get very disoriented at night. Being disoriented at night means you are not making, you're not making as best decisions as you possibly can. So you want to slow down, whether it's night, fog, shallow water. You always want to slow down to give yourself more time to process. So if there's something happening, whatever it is, maybe you have a lot of distractions. You're having a big family gathering or something on board, and you're not processing all of these navigation things as quickly as you usually do. You want to slow down to give yourself more time to figure out what traffic situation it is, more time to figure out what navigation situation you're in, just more time. So slow down and give yourself more time. Easier said than done. I can't tell you how many times I've been in restricted visibility. You're supposed to slow down to a safe speed, but the captain says, nope, keep going. I want to go full speed ahead. It happens a million times. But as a prudent mariner, slow down when you have restricted visibility or at night, if you just don't have time to process it and can't or don't have that orientation. Okay. Use your tools. Use the depth sounder, electronic plotter, the radar. Use all those tools that you have. Maybe you don't have any of them, but maybe you have some of them. And you want to use those tools before the fog comes or before it gets dark. You don't want to be trying to navigate by the radar for the very first time when the fog rolls in and you've never seen what a radar picture looks like. That makes a lot of high anxiety and stress. So you want to be comfortable with those tools beforehand. So when you get to a situation that is less comfortable, you already know how to use them. You already know how to interpret that screen and know what all of those numbers and letters and blips are telling you. So yeah, there's that. My last little guy on here is celestial. Celestial is only used at sunrise and sunset. We have to have a horizon and a celestial body, whatever the celestial body is, in order to plot our positions by celestial navigation. So I think a couple of you guys were in my celestial class, but anyways, yeah, that is all I got for you guys. What kind of questions do you guys have? You guys all right?
Great, can you hear me?
Yes?
Just like if you were to do long distance at night, can you put you on autopilot? But do you need, basically, I'm not sure, obviously you need to sleep too, so how does this work?
So if you were doing like an ocean crossing, you're saying?
Yeah, or even if you're here, wanted to go to Mexico or Cabo, you know, and not stop at night, you know, and go on.
Yes, if you are solo navigating, that is a big challenge. You don't get much sleep, or you get very intermittent sleep. You know, technically with rules of the road, you're supposed to have a lookout at all times. So if you have 2 people on board, you can swap, or you can be navigating in an area where there's, you know, no traffic, you know, open water, you know, further offshore, and have those alarms and tools set so if you go off course, it sounds a large alarm. If there is a target acquired within 5 miles, it sends a large alarm. You have your radio up. You have all of those tools loud enough so that you can hear those alarms when something is happening. So if you, and I would definitely slow down or just hove to, as we call it. I know most sailboats crossing don't actually hove to at night. They just keep going. But
I guess I have to practice during daylight about all these alarms and make sure they work.
Yes, you want to make sure everything's working. I don't know, it's kind of that risk. I would not recommend it, but I mean, people do solo navigate, that's a thing. But if you have, you know, more people on board, the safer it is.
Yeah.
Yeah. All right. Well, that is all I have for you guys. You guys are more than welcome to email me any questions along the way. If you guys are practicing or taking other classes, I'm always available to answer anything or retake a class. A lot of people like to do that. I don't know, for me, the next classes I'm teaching, I'll be doing Coastal Nav 1 and 2 again. And then this summer, I'll be doing Celestial. And hopefully we will be getting our new simulator. I don't know if anyone's been down in Newport lately, but the new building is getting almost completed in March, and it is going to be pretty awesome. We're going to have full simulators and radar practice, and I'm hoping to do a little radar familiarization for recreational boaters as well. But it hasn't been installed yet. So that is on the horizon of cool things that are coming, but I don't know when exactly. So yeah, that's what I got.
Well, great. Well, Bree, thank you very much. I learned a lot. Have a nice holiday, and I'm sure I'll be talking to you at some point. Everybody else as well. Take it easy.
Yeah.
Bye-bye.
Stay safe and have a great holiday.
Thank you,
everyone.
Bree.
Yeah, thanks, Bree. Thanks, everybody.
Thank you, Bree.
Thank you, guys.
Goodbye, everybody.
Good night, all.
I'll see you for Celestial next summer.
Cool. All right.
Me too.
Yeah, me too.
Cool.
Bye.
Bye.